Good afternoon everybody. In today's tutorial we are going to take on some problems on Thevenin's theorem, Norton's theorem, max power transform theorem and superposition theorem. This is the first problem where we need to find the Thevenin equivalent resistance and voltage across RL. Okay, so this is the load resistance. So we need to find out what is the resistance, Thevenin resistance as seen by RL into the circuit. So we remove RL and we see into the circuit from these two nodes and find out what is the Thevenin resistance and also the open circuit voltage, which will give us the Thevenin equivalent voltage. Okay, so even if it is not specified the terminal names A and B for your exam sake, RL itself indicate that is the load resistance. Okay, so automatically the ports the output ports will be defined across this RL. Okay, so be careful with what you write in exams. So once I write RL, I have given the problem RL stands for load resistance. Okay. So now this is the equivalent circuit which we need to formulate. This is the original circuit. So we need to find out what is the voltage, Thevenin voltage and Thevenin resistance. See, Thevenin voltage, like I said before, we don't have to really use paper and pen in these simple circuits. Just visually we can see it and we can find out what is the Thevenin voltage. So the simplest option is to use superposition theorem out here. Now when I use to find if I have to find out what is the voltage between these two nodes, so RL is removed, right? So let's use superposition theorem and let's also discard this I source. So this also will become open circuit here. Now since RL is not there, no current will flow into this 2 ohms. Okay, so whatever is the open circuit voltage available will be across 6 ohms resistance, right? So this is 18. So we can use the voltage division rule, 18 into 6 divided by 3 plus 6. So 3 and 6 are there in series across 18 volt. So just seeing this circuit, you can say that the voltage, open circuit voltage available here, okay, if there were no RL and I also, it would be 18 into 6 divided by 6 plus 3. Okay, so this is similarly, if this is not there, then only this current source is available here. Again, see this, there is this 2 ohms is an open circuit, so there is no current flowing in it, so the potential will be 0 across. So you remove this 18 volts, so the 6 and 3 are going to be in parallel. So what is the voltage? It is going to be 1 ampere current into the parallel resistance between 6 and 3. So straight away you get this formula and you can write the voltage to be as 14 volt. Is it okay, Gagan, Abhinav?
Yes, sir.
Yeah, correct?
Yes, sir. Yes, sir.
So these circuits can be easily tackled using superposition theorem. Okay, just by visual inspection itself, without wasting too much of your time doing mesh analysis and all, we can get the answer for this. Similarly, to find out what is the Thevenin resistance, see this is 2, this is going to be open, this is going to be short, so 6 and 3 parallel and in series 2. Okay, so straight away we can write that equation and get the volt. Sorry, this has to be 4 ohms. Okay, this written 4 volts, so this has to be 4 ohms. Okay, so this is the equivalent circuit, Thevenin circuit, where 14 volt and 4 ohms. Okay, so these are the kind of problems you can expect in your exams also. So it is pretty simple. So time might be a factor, so that is the reason you need to use the optimum method. Okay, so in most of the cases superposition theorem will get you answer faster. Okay, now let's take one more problem in which find the Thevenin equivalent resistance and voltage. So now you have an dependent current source which is fitted out here. So we need to so the things are not straightforward, but then let's first write an equation out here for this particular mesh. So it is 4 volts, right? And now if you see the current is going to be in the negative direction out here. because it is given, the arrow is given from bottom to top. So this voltage is going to be negative across R1. So what is the current which is going to be flowing into this? It is the same current, because this 3 ohm is, we left it open, right, for finding out the Thevenin voltage. It is open circuit voltage, so there is no current flowing into this. So the voltage across R1 will be this current, that is Vx by 4000 and 2k stands for 2000, right? So 2000, so this minus has been put because the current is in the negative direction, and plus Vx excuse me, this Vx is the terminal voltage available here, plus Vx. Okay, so once we do that, so this becomes an I think an minus 0.5 plus 1, so it will become 0.5 Vx. So that is Vth straight away, right? Now the next question is to find out the equivalent resistance. Okay, now the equivalent resistance is, mind you, it's not 3k plus 2k, because there is a dependent source also here, so we can't directly do that. So it is the best option in this particular case is to find out an ISC and then write the value of the find out the value of the Thevenin resistance by dividing Vth by ISC. Okay, so if I short these two terminals, okay, so what will be the current which is going to flow into this resistance? If I short these two terminals, if you see, if I short these two terminals, the total voltage available is 4, and you have these two to find these two, because this is shorted out here right now, right? So Vx has become 0, right? So if Vx is 0, what happens to this dependent source? 0, right? So there is no current which is going into this, so this current source value is going to be 0. Okay, that means you will have to leave it as open circuit, mind you. Okay, had it been an dependent voltage source, okay, if suppose it's a dependent voltage source and Vx and into something, and Vx is equal to 0, then that would become a short circuit. Okay, whereas this is a dependent current source, I am going to short these two terminals out here. So when I short to find out I short circuit, so the output voltage has the Vx has become 0. So this is an current source which is providing 0 current, so that is why this has to be left as open. Right now, if this is open, then the short circuit current will be merely 4 divided by 3k plus 2k 5k. Is this clear to all of you? How we have?
Yes.
Okay. So only be careful with that. Now you understood why this is left open?
Sir, I did not understand how we got minus 2000, sir. Like I did not follow the start.
This one. Okay. See, we are going to write an loop equation here. This is 4 volts. Okay, and now there is no current flowing into this 3k because we are taking output voltage here. And what about the current? This is Vx divided by 4000. The arrow is pointing up, so this is going to come in the opposite direction, right? So Vx by minus into this is 2k 2000. Is it okay now?
Yes, sir.
Okay, plus Vx. So this terminal voltage is given as Vx. So with that we get here. Is it okay now? Okay. And all
yes,
of you are clear how we got this short circuit as 4 divided by 5k, right? And now to find out RTh, V divided by Vth divided by ISC, you get an 10k out here. So this 8 divided by 4 and 5k goes on top. So 8 divided by 4, 2, that will be 2, and into that 5k which comes to the numerator, you get 10k. Is it understood how to tackle these kind of problems? Okay. So this is the final answer out here. Okay, now this is another question, the third question, where we say find the value of the maximum power transfer in the circuit of the shown figure. Okay, so we have RL out here, this is the load resistance. We need to find out what will be the maximum power that will be transferred from this circuit to the RL, and what will be that value of RL for which the maximum power transfer would happen. Okay, so that we learned the theorem that whenever RL is equal to the Thevenin resistance, that is the time where maximum power from this entire circuit will be transferred to RL. Okay, not that the maximum power from 12 volt or to from this entire circuit. If we consider as a single source, then whatever for that VTH and RTH values, then when RL is equal to RTH, that is the condition where maximum power will be transferred to this RL. So we need to find out now the value of RL and also the corresponding power. Okay, again here we need to find out the VTH. Okay, so if we follow the same philosophy, right, and RTH is, if you see from here, okay, if you see from seeing from the output side port, so this is it would come to total 9, because this is going to be open circuit, this current source. 2 plus 3 is going to be 5, and 6 and 12 are going to be in parallel, right? So 6 into 12 divided by 18, and 2 plus 3 5, so you get 9. Okay, is it understood? How did I write this? 5 plus 5 is nothing but 3 plus 2. This current source has been left open circuit, this has been shorted out here, so 6 and 12 are going to be in parallel, so I get 9 ohms. Now similarly, to find the Thevenin voltage, again I am using superposition here. This is going to be open for to find out what is the voltage with respect to this voltage source. So this is open, and when it is open, there wouldn't be no current would be flowing in 3 and 2, so they become irrelevant. So we have to find out what is the voltage across this 12 volts. So 12, this is the power supply, so 12 voltage division rule, 12 into 12, and this 18 is nothing but 6 plus 12, so 6 plus 12. Similarly, when this current is flowing, I am going to put a short circuit here. This current is flowing here, right? It is flowing across 3 ohms plus parallel of 6 and 12. Okay, 6 and 12 parallel will be 4 plus 3 7, so this 2 amperes into 7. So this is the Thevenin voltage, which is 22 volts. Okay, this is 9 ohms. Is it clear to all of you how we got these values? Okay.
Yes, sir.
Yeah. Okay. I'm just skipping. I'm writing these equations directly because you need to practice and start doing this to save time for in your exams, as well as when you are going to write competitive exam. Okay. Once you start writing equations like this, so you will start saving upon time. Okay. Now that is so the load resistance at which the maximum power would transfer is now RL is equal to 9. Okay, that is known, and the P maximum, the power for maximum power that can be dissipated in RL or can be transferred to RL will be V square by R. Okay, so V square by V by 2 will be the power which will be available, right? Total V is 22, out of which half of the voltage will be dropped across the RTH, and half of will be available across RL, right? So that V will be 22 divided by 2, right? So you need to 22 square divided by 4, V square by R. This is the power which is max power which is available across the load resistance. Okay, is this formula clear to all of you? Shashank? Yeah. Okay. So in the maximum power that will be delivered by the source will be double of this. Okay. So out of which half of that will be available across RL, and half of the will get dissipated across RTH. Okay. So that needs to be clear. Okay. Now the next problem is find the Thevenin equivalent circuit of the circuit shown A and B. Okay, across A and B. Here again it's written RL. So we need to find out what is the Thevenin equivalent resistance and the voltage across A and B. Okay. So if you see, this circuit appears to be complex, but if I redraw it, so this voltage source has been shorted out here. right? So now this is A and B. Okay, A is on the right hand side and B is on the left hand side. So if I redraw it, if you see from A to B, there is one 12 ohms and then 6 ohms and then it comes to B. Okay, from A 12 ohms and 6 ohms and then B to B. And similarly from A there is a 4 ohm, 3 ohm and it is coming to B. So from A 4 ohm, 3 ohm and it is coming to B. And also this, the junction of 6 and 12 and 3 and 4, they are shorted. So this is the junction between 6 and 12 and 3 and 4. They are shorted. So if I redraw it like this, if you see, now this becomes pretty simple. 4 and 12 are in parallel, 3 and 6 are in parallel, and those two parallels are in series. So Thevenin equivalent resistance will be R1 parallel to R2, right, plus R2 parallel to R4, right. So the 6 and 3 are parallel to each other, 4 and 12 are parallel to each other, and then they are in series with each other. Okay, is it clear to all of you? Okay.
Yes, sir.
Okay.
Yes, sir.
So, okay. Now let's take one more problem. Find the equivalent circuit shown in figure, Thevenin equivalent circuit. Okay. Now, if you see these two branches, see, irrespective of the current which flows here, okay, the terminal voltage across this top and bottom rails is 72 volt, because there is an ideal current voltage source which is placed here. So this voltage will be irrespective of whatever is the currents, irrespective of what currents flows in the other branch, the terminal voltage from here to here will be 72. So this B and A straight away we can find out using the voltage division rule, right? So V1, which is this voltage, okay, it is right, this is going to be 72 into 6 divided by 6 plus 3. So this is the voltage and plus minus. Similarly, this voltage is found to be, okay, 72 12 into 72 divided by 12 plus 4. Okay, so this is the voltage division rule. So these are the voltages which has been found, and then by using KVL across this loop, okay, to find out the voltage between these two terminals. So we can subtract these two voltages and get the voltage 6 volt. Okay, now you can also do otherwise you can find out what is the voltage across 3 ohms and 4 ohms, and then take the difference of the voltage which is available at this node and this node. Okay, is this clear to all of you? Yeah. Similarly, to find out the Thevenin resistance, so if we short this, it becomes the similar circuit like we did here. Okay, so this and this are parallel, this and this are in parallel, and then you take the total resistance. Okay, now here 12 and 6 will be in parallel, 3 and 4 will be in parallel. So and then you can find out what is the combination will be in series. So you will get 5 ohms. So this is an same problem which we did. Yeah, you have a question? Oh, sorry. Yeah, so
I am not able to understand how we got the 6 by 6 plus 3. Like for V1,
for V1, how we got 666. This is a voltage division rule, right? So
yes,
if you have a voltage out here, right, what will be the current flowing here? 72 divided by 6 plus 3, 6 plus 3, 9. That is the current which will flow here.
Yes, sir.
Okay, so what will be the voltage? Okay, voltage will be 72 into 6 divided by I into R. So it will be into 6. Okay.
Yes, sir.
I told the voltage division rule is it comes from there. So we need to, this is the voltage division rule. Okay, is it okay now? Yeah, okay. Okay, now this is again, till now we have taken some problems on Thevenin. So let's take an example of Norton equivalent. We need to find out what is the Norton equivalent. Okay, so what will be the Norton resistance? Can anybody, just seeing the circuit, can we tell? Okay, this will be open circuit, this will be short, so this will become 8 plus 8 plus 4, right?
Sir, it is calculated just like normal Thevenin resistance, right?
Yeah, correct. So Norton resistance is exactly same as,
So is it 4? Is the normal resistance 4?
yeah, it will be 8 plus 8, 20 in parallel to 5, right? Similarly, if I have to find out the short circuit current, okay, I remove this 5, this will become an short out here, right? So and then I can use the superposition theorem. That will be the easiest method to do it if I just short it here. So these equations we should be able to write it in one go. So Thevenin resistance, like you rightly said, it is 4. To find out the short circuit current, okay, can somebody tell what could be, if I write there will be two components, right? For the 2 amperes component, what would be the one? 2 into something divided by something we need to write. Current division rule. Make a wild guess, no issues. We'll learn that if you do that, it will become, things will be very simple for you later on. This is 2 amperes, right? This we have to find out what is the short circuit, just because of the, we are going to use superposition theorem. So assume this is not there. So this will become short. Okay. So it will be 2 into what by what? Anybody?
Sir, we have to divide current between the 4 ohm and then the 16 ohm, right?
Correct. The current has to be divided between 4 ohm and 16 ohm. So it will be 2 into 4 divided by 20. Correct? Isn't it?
Sir, why will it be 20, sir? Yes, sir. Total resistance.
Total will be 20, right? Similarly, now we leave this open and find out what is the current from 12. So what would it be? Anybody? This
then 4 and 16 are in series now.
Yeah, it is in series. So it will be merely 12 divided by 20, right? So I can write 12 divided by 20 plus 2 into 4 divided by, this is 1 ampere. Is this thing clear to you? Okay, with little bit of practice you can go through this. I'll upload this PDF. Okay, we don't start writing loop equations. You will waste time in your exams. Okay, try to visualize the circuit and straight away come to this step of superposition theorem. Okay, for all these kind of problems. Okay, so with little bit of practice you should be able to write these equations directly just seeing this circuit. Okay, so you can try it out probably in a few more examples which is there in the textbooks. Try using superposition theorem, you will reach the answer quickly. Okay, so this is the equivalent Norton circuit. Yeah, tell me.
So why do we remove 5 volt for 5 ohms for the second case, sir? We counted it for taking Thevenin resistance.
No, we are doing a short circuit current. We are interested in finding out the short circuit current. So once we short these two terminals, so it is like 0 ohms parallel to 5 ohms.
Okay, sir.
Right. So that is the reason we have taken out 5. Is it okay? Okay.
Yes, sir.
Okay. So let's take one more problem. Okay. Now here we need to find out the voltage between. Okay, V CE. Okay, this is the terminal C and this is E. Okay, now we have to find out what, and V A and G. Okay, VCE is nothing but the, okay, from here to here we move this path. Okay, so this is whatever is the voltage across 5, and then you have one 10 volts, and then you have another voltage which is available 5. So this circuit at one go it might appear pretty complicated, but then it is very simple. Can this current which is flowing in this loop, can it go there? Will they have any relations, or they'll be totally independent?
They'll be independent, sir.
Yeah, they'll be independent. See, there's only one wire which is connected between this loop and this loop. Okay, so there will be no current. This current will be totally independent of this current. Okay, this diagram, the way it is made, it just looks complex, but it is a pretty straightforward and simple circuit. Okay, so what we can do is find out what is this loop current. This is 20 divided by 6 plus 5 plus 9. Okay, 1 ampere current. Similarly, here it is 40 divided by 8 plus 5 plus 7, this is 2. Okay, only thing is the direction of the current is important in both these cases. It is going to flow, here it is going to flow clockwise, here it is going to flow counterclockwise, right? Now we need to find out the voltage between C and E. Okay, so C and E is from C, since it's going to flow from top to bottom, and the current is 1, so 1 into 5, we are going to write a minus 1 into 5, right? And then from B to H, it is 10 volts. This is 10 volt, and then here also the current is going to flow from top to bottom, so it is minus 2 into 5, so minus 5 volt. Okay, is it clear to all of you? How did we get this minus 5 volt? Okay, Gagan, is it okay?
Sir, why are we taking -1, sir? Can you tell me?
Yeah, -1 is because we are taking the voltage between C and E. So we are moving from C towards E.
Yes, sir, got it.
Current which is flowing is in the opposite direction here. Okay, okay. Now we are finding the voltage between.
Then it should be plus 2 only, no, sir? If you're doing it like that, because current is going from E to H, so it'll be going.
Pardon?
So you're taking -1 because current is going opposite to the direction we intended.
Yeah.
So then for E case, it should be plus 2, no, sir?
No, E also the current is, see, 40 volts here. The current will be in the counterclockwise direction. Current, see the 40 volt, how it's placed here. So
yes, sir.
Current will be flowing from E to H, whereas we are moving from C to B to H to E.
Oh, okay, sir.
Yeah, okay. Okay, now similarly to find out the voltage between A and G, if you see here, 6. Okay, this is now positive direction, the current is flowing, so 6 into 1, and then 10 volt. Okay, this is 10 plus, again 7, the current is in the positive direction, so now here we get 30 volt. This is all positive. Is it okay?
Yes, sir.
Yeah, okay. So I will take one last problem. Here again you have this voltage V, you have a dependent source out here, so we need to find the value of V here. Okay, this is V by 3. Now if you see here, again there is one source here, 2 source here, 3 source here, and this is a dependent source. Okay, again we will use the superposition theorem. So we'll keep 1 and remove 2. Okay, and then again, so we'll have to do it thrice now. Okay, we'll make 3 circuits taking one source at a time. Okay, like I mentioned in the theory class also, the dependent source in all the 3 cases, the dependent source will be there. We cannot remove the dependent source. Okay, so these are the 3 equivalent circuits out of this, with taking only one source at any given time. So this is 30 volt. This becomes open circuit, and this becomes a short circuit. So this is only one source which is taken here. Here in this case, only the current is taken here. So this voltage source is shorted out here, and this voltage source is also shorted here. And in the third case, if you see here, these 2 have been removed. So only one source, this 20 volt source, is kept here. So we make 3 different circuits. Is it okay? So having done that, then we need to we can write the node equation out here. Okay, in this case, so it will be if you see the current which is coming into the node is 30 minus V by 6. This is the resistance, and here it is going to be negative because this current will flow out of the node, because V is positive. We are taking V divided by 3, and this voltage again, if you see, V by 3, this is coming into the node, so V by 3 minus V by 2. Okay, is it clear? How do we write this node equation? Okay, only the polarity of the currents, according to the polarity, whatever we have decided, if the current is coming in, it is going to be positive. So accordingly we have written this equation. So coming in will be 30 minus V by 6. Here it is going out, so it is going to be, because V is here and it is ground out here, so it will be minus V by 3, the current is going out, and the current which is going to come into this is going to be V by 3 minus V by 2. Okay, so with this we get 1 voltage out here. Now in the second circuit, again if you see, we are going to write a node equation here. So here it is V. Now this is ground here, so the current will flow out into this resistance, so it is minus V by 6. Okay, this is ground, and this is again going out, so we have written minus 5. This is again going out, minus V by 3, and here again V by 3 minus V by 6. Okay, because V by 3 is this voltage, and this is V, so V by 3 minus V. I guess this should have been 2, right, in the denominator out here. This should have been 2 actually out here. Okay, so if I solve that, I'll get the voltage V equal to minus 6. In the third circuit, again if you see, if I write the node equation here, it is V by 3, and then again V by 6, and then what is this? Okay, this is voltage V by 3. I think we are finding out the currents out here, and then multiplying it with this, you are getting the currents. You are trying to find out the current out here, and then you get the voltage out here, right? It is. So 3 independent circuits we try to find out. This is 3 and 6, they are taking it in parallel. Okay, so that comes out to be 2 ohms. Okay, that 2 ohms and 2 ohms, okay, in series. So I into 2 into 2, so that is the voltage across these two resistors. Then you have 120 volt and you have V by 3. So this is the equation which is written. So how does this equation come? 20 volt. Okay, 6 and 3 has become parallel to 2. Okay, so the current flowing, I have taken it as I. So this 2 plus 2, okay, that is the voltage across these two resistances, and there are 2 voltage sources. One is 20 volt and one is V by 3. So with that you find out current, and then what is the voltage V? That voltage is again, once the current is 6 amperes, V is nothing but the current flowing into the parallel of 6 and 3. 6 and 3 parallel is 2 volt. Is 2 ohms, so 6 into 12 volts. Okay, that's how we get 12 volt. Now you add up, this is superposition theorem, so we add up these 3 voltages and we get the net answer to be 6 volt. Is it clear to all of you? In these two cases we have written the node equations, and here it is, since we can't write node equation because there is a current source available here like this, so we can't write straight away the node equation. So instead of that, we have found out what is the current in this loop, because these are in parallel, so this becomes a single simple mesh. So we found out the current first and then we found out the voltage. Is it clear to all of you?
Yes, sir.
Okay, so with this we come to end of